Hello dear students, this is your engineering mathematics 3 lecture. Today we are going to discuss Jacobi's method. This method is used to solve the system of linear equations, and this topic is from 5th unit, numerical methods. Now we are going to solve the example using Jacobi's method. See the example: 10x plus y plus z is equal to 12, 2x plus 10y plus z is equal to 13, 2x plus 2y plus 10z is equal to 14. Okay, this is the system of linear equation. Now you find the values of x, y, z from these three equations one by one. Now how to find the values of x, y, z here? There is one concept or condition. In suppose in equation 1, the coefficient of x is 10, coefficient of y is 1, coefficient of z is 1. So the maximum coefficient is here 10 and it is of x. So here in this equation you find the value of x. In second equation the maximum coefficient is 10 and it is the coefficient of y, so you find the value of y. In third equation also the coefficient of maximum coefficient is 10 as compared to the coefficient of x and y. The coefficient of z is a big value, so you find the value of z. Means in every equation you first find the maximum coefficient and then you find the value of that particular variable in that equation. That is the condition, that is the way to find the values of x, y, z. Here from equation 1, 10x is equal to 12 minus y minus z. So x is equal to 12 minus y minus z upon 10. And equation from equation 2, the value of y is 10y is equal to 13 minus 2x minus 2. And so y is equal to 13 minus 2x minus 2. Sorry, minus z, not 2, it is z upon 10. And from equation 3, 10z is equal to 14 minus 2x minus 2y. And so z is equal to 14 minus 2x minus 2y upon 10. Okay, so from 4, 5, 6. Now we are going to solve the system of linear equation using Jacobi's method. And Jacobi's method is a iterative method. So by iteration, we will find the values of x, y, z. So the first iteration, in first iteration, you put x, y, z is equal to 0. Initial values of x, y, z are zeros. And then equation 4, 5, 6, it will be, if, in equation number 4, y and z are 0. Then x is equal to 1.2. In equation 5, put x and z is equal to 0. So the value of y is 1.3. In equation number 6, put x and y is equal to 0. So the value of z is 1.4. So these are the values of x, y, z in first iteration. Now the second iteration, in second iteration, the initial values are here. The first iteration values. First iteration values are the initial values for second iteration. It means x is equal to 1.2, y is 1.3, and z is 1.4. Now you put all the values in equation number 4, 5, 6. In equation number 4, 5, 6. So that you will get the values of second iteration. And the values of second iteration are here. You put here the values of x, y, z in 4, 5, 6. So that you will get the second iteration values. X is 0.93, y is 0.92, z is 0.9. So these are the values of second iteration. Now third iteration. Now for this third iteration, you use the previous iteration values as initial values. So in second iteration, the value of x is 0.93, the value of y is 0.92, and the value of z is 0.9. So use these values are the initial values. Put in equation 4, 5, and 6. So that you will get the value of x, y, z in third iteration. And so the third iteration values of x, y, z are here. X is equal to 1.018, y is equal to 1.024, z is equal to 1.03. So these are the values of third iteration. Now, how many iterations we have to do here? Your answer, it must be correct up to 1 decimal place, 2 decimal places, 3 decimal places. At that time, you stop there. Now here, In first iteration, the values of x, y, z are here 1.2, 1.3, 1.4. In second iteration, the values of x, y, z are here 0.93, 0.92, 0.9. Means variation is there in the values of x, y, z in first and second iteration. In second and third equation, you compare the values of x, y, z. The values of x, y, z are here. In third iteration, 1.018, 1.024, and 1.03. If we compare these values with the values of x, y, z in second iteration, again the variation is there in second and third iteration. So you go for the fourth iteration. Now, while going to fourth iteration, use the previous iteration values as initial values. Means in third iteration, the values of x, y, z are here 1.018, 1.024, and 1.03. Use these values as the initial values for the fourth iteration. Put all the values of x, y, z in equation number 4, 5, and 6, so that you will get the values of x, y, z in next iteration. And in next iteration, the values of x, y, z are here. X is equal to 0.9946, 0.9934, 0.9916 here. So again, the variation is there in third and fourth iteration values. The values of x, y, z. The third and fourth iteration values are here, showing the difference. So you go for the fifth iteration. Means you use the previous iteration values as the initial values. That it means here in fourth iteration, the value of x is 0.9946. The value of y is 0.9934, and the value of z is here 0.9916. Okay, use these values as the initial values and put in equation 4, 5, and 6, and you solve. Again, you find the values of x, y, z. So the values of x, y, z are 1.0015, 1.0019, 1.0024. So these values are approximately equal to 1, so nearer to 1. So the answer, your answer is here. And the values of iteration 4 and 5 are nearer to 1. So you stop here at fifth iteration, and your answer is here for x, y, z 1, 1, 1. So this is the solution for the system of linear equations by using Jacobi's method. Jacobi's method is the iterative method, and you always do 3 to 4 iterations or 5 to 6 iterations to get the accuracy for your answer. So this method is over here. This session is also over here. Thank you.